I'm going to talk today about an aesthetic-based fitness measure and a framework for guidance of evolutionary design in architecture. I'm happy to have you as audience. I am Manuel Mühlbauer. I am founder of Future Immersion, and my co-authors on this paper are Burry from Swinburne University of Technology and Andy Song from Royal Melbourne Institute of Technology. Let's see. I structured my presentation like this. First, I'm gonna talk about the problem that we address in architectural design process with our framework. Next, I will talk about an aesthetic-based fitness measure and then embedded in the framework for guidance, which is the second part of the research. Then I will introduce you to the experimental setup we used before I talk about the case study work. Finally, I'll wrap up talking about the conclusions and the future work we propose to extend this research. The problem in architectural design that we are confronted with is that optimization usually happens very late in the design process and often is only applied to building elements. So the building shape is usually not taken into account when optimizing a building. There are additional optimization benefits that can be captured by optimizing the building shape, the building envelope, very early in the design process. And this is what we suggest by proposing this framework for designing the architectural shape interactively in an evolutionary system, because early in the design process, the shape can be changed easily without generating excessive cost. An aesthetic-based fitness measure is necessary to kind of guide the user through the process of generating different shapes and exploring them. First, an initial image input is introduced by the designer as a design reference, because in architecture, designers like to work with those kind of references. This could be basically anything like a 3D model or video, but we used an image for this research to explore using a similarity measure to compare this image input with the design solutions. In this case, we used screen captures of the 3D shapes generated in the process. This similarity measure was also used for population reduction to omit similar shape solutions. The designer then doesn't see similar solutions coming up again, so the design system kind of has a more creative, stimulating effect. This also allows to compute excessive fitness functions with reduced computational cost. Shape comparison, what I just introduced, is the main mechanism of the guidance system. It provides the search with direction and online classification using the data interactively generated by the user in artificial selection is used as another guidance mechanism in this procedure. The designer can introduce the initial image input along with the genetic parameters in a first interface during the process, so that it is clear that the designer kind of wants this direction throughout the search. This additional interactive stage at the start of grammar evolution extended a kind of interactive approach common in grammar evolution. The shape comparison by similarity measure worked by comparing normalized image histogram of the reference image with the already mentioned screenshots of the shape designs. The combination of the three different distance metrics defined a similarity measure with more features than just using one of those distance values. And I already mentioned that there are multiple modes of applying this similarity measure inside the computational design system. During the process, the designer then has the option to select different shapes in an interactive interface. It always shows 6 design solutions to the user, as long as they are available in the pool. If there are too many similar solutions, then it might happen that there are less, but usually the 6 solutions are there as a pre-selected set of shapes for the designer. The user data generated by selecting different design solutions as preferences and also objecting the other ones is then used as input for a decision tree algorithm to train classifier for then further predicting aesthetic preferences during the process. This guidance procedure combined fitness evaluation of quantitative and qualitative criteria, and thereby combining what the computer is really good at, like calculating fitness performance, and then also thinking about introducing simulation there and integrating the human in the loop, where the human strength is like really thinking about a solution from different perspectives, and then not only using the aesthetic while there is the focus in this discussion, but also the implicit knowledge of the designer about design solutions and particular design cases. On the bottom right of the screen, you can see the fitness function, which is a combination of performance measure, which is then added up with the aesthetic fitness measure. The aesthetic fitness measure consists of the distance values computed by the similarity metrics and a factor by the predictor that kind of infers the designer preferences during the process. Therefore, evaluating form and function of architectural design solutions, which is kind of the core concept, the kind of double code that architecture uses for evaluating different design solutions. It also combines performance and perception-based modes of evaluation. The framework for guidance is grammar evolution based on genetic programming, which is then extended with the kind of interactive measures that we introduced: shape comparison for processing the image input and online classification based on artificial selection. You can see on the flow chart to the left the GP process, which is there extended by a shape comparison during the first couple of generations to already give the searcher direction in this automated phase when the designer doesn't have additional artificial selection input, so that the designer can start evaluating already from an advanced position. Also, the similarity matrix is already used for reducing similar shapes. After the first couple of generations, and then the designer starts evaluating every 10th generation what the design preferences are, and then online classification comes into the fitness function, and all 3 measures work in the fitness function. During automated phases of evaluation, the aesthetic fitness measure is used to predict the preferences of the designer, and during interactive stages, the designer then selects shapes to extend the data set for training the decision tree classifier. The framework for guidance started with kind of exploring the research on representations. The representation is always crucial when it's about computing shapes, especially in architecture where there are so many functional and spatial considerations that need to be taken into account. We started by thinking about 2D grammars. Architects usually think in floor plans and sections. So this is the traditional starting point of architecture. We then said, okay, again, if we start designing there, then the building shape itself and all the benefits that come along with optimization of the envelope can't be used. So we moved on and thought about, okay, thinking about 3D grammars and also about house grammars, which then combine both approaches. We didn't follow along that line because we thought that the kind of expressive aesthetics that is used in larger buildings where there is really the need to be more sustainable kind of comes in this complex shapes. And moving along, evolutionary computation, multi-objective optimization, thinking about the similarity criterion and introducing that, and sticking then to the focus on interactivity and really developing those approaches of interactive optimization to increase the designer engagement during the process. The designer often steps away from using optimization strategies because they have a long process and there's not a lot of interaction. So we brought a solution to this problem. The experimental setup during the case studies you can see on this slide. On the left side, the generic parameters used during the optimization process. On the right side, you can see the grammar we used in Becker-Nauer form, building complex shapes from simple shapes by applying shape grammar rules. Shape grammar representation is a combinatorial approach using a set of geometric transformations. You can see some examples on the right-hand side of the screen, how simple shapes are then combined to complex shapes. And applying those rules in different order generates different shapes. This formal process of shape generation has a big advantage. It is comprehensive and designers can understand how the geometry is generated. So also after the search from the program tree, the geometry can be reconstructed. We use strongly type generic programming to ensure the grammar consistency, which is important in this case, but even more important when bringing into consideration spatial and functional thoughts. Grammar translation was then used as the mapping progress from genetic programming trees to 3D shapes. For the case study, we designed a language museum in London. It is about communication, so we decided on having this design motive of the intimate communication between two people as a design inspiration, and brought this design idea to life by thinking the spatial program as two distinct parts, the gallery program and also the exhibition part and the learning spaces. and merge those two spatial parts again to one shape. During the interactive exploration of the 3D shapes, designers chose different solutions, always thinking about what the final outcome should be, these kind of elongated shapes that give a boundary to the site and allow intimate communication between the users of the museum from the entrance side. Then responding also to the functional program, those considerations were important by getting this aesthetic expression of the intersecting crystals in the right proportions. And also the key design motive emerged during this interactive shape design. Moving on in the architectural design process, then the architect started fine-tuning the architectural shapes from an architectural aesthetic position, which is always formal on the one side, and also thinking about the implications that a perception of the shape might have. In the next step, the levels were introduced, and the considerations about room heights, for example, start coming into the discussion, and also first considerations about the floor plans, which we then developed in response to the shape, but also to the side. It's kind of working from both sides. On the one side, the functional and programmatic aspects, and on the other side, the building shape that needed to be adjusted in certain positions to encapsulate the architectural program. And finally, testing the design on the virtual side. The results of the case study are that the framework supported the discussion of aesthetic implications of different architectural shapes, which is very important. Usually, as architect, I start designing one shape and then, okay, do I like it? What kind of aspects can I learn about the case from it? But looking at a variety of different expressions of an underlying aesthetics allows to also think in a progression, and therefore narrowing down the kind of search space for architectural design solutions, not only in the design system, but also in the mental process and progression. Also, the spatial qualities and the aesthetic of the building could be explored on those different design options and then critiqued from different perspectives in a collaborative process. This kind of enhancement of the communication was something that emerged really now in looking back and reflecting on the process. But this is another point that needs to be made. The negotiation of distinct design features is something that is also specific about using the guidance framework for evolutionary grammar. That is something that could be extended in the future, like identifying those features and then also pushing them as a kind of subset of the shape. But before I talk about the future work, let me come back to the research conclusions. This novel approach to interactive shape design supported aesthetic decision-making as part of the creative process and enhanced designer imagination. So there's have two things that play together. On the one side, going back and forth from the computer and working creatively with those shape solutions is something that is great in this design process, because some results of the creative process can then be input again as image, and the exploration can be reset. Also, the architect thought about design solutions and aesthetic solutions that they might have not come up with without this kind of system, especially when thinking about complex shapes, the drawing and the kind of representation of the design as an image in the cognitive process is kind of getting quite cumbersome, maybe. The adaptive system also accounted for this divergent character of architectural design process. That's not a linear process that converges to one point and there's a best solution, but exploring a variety of different design solutions, learning about the design case and then coming back and adjusting the representation to move forward. The study showcased the application potential of the framework for interactive exploration of design spaces. We already heard about this topic throughout the session. In generative design, it is important to explore a design space, and often single design solutions are chosen and then cataloged. And this interactive framework allows to explore a design space more pinpointed, with having the direction from the shape comparison and also the guidance through the online classification, have extending that trajectory of aesthetic consideration. In the future, we plan on applying this concept and this framework in mass customization of residential buildings with a more complex representation, similar to the house grammar I mentioned earlier. And also another step that we consider is transferring this interactive design system to part and assembly design for industrial products, because it is a similar problem, but with different considerations in terms of the restrictions of how shapes can come together and be assembled in a functional process to a machine. On the bottom of the slide, you can see the process that we envision for that. We have the human-in-the-loop design system and the designer, and working on the concept of a shape or the expression of a shape interactively. Then the next step again is going to prototyping. So this is what would be, for example, the museum in the case study. This would be an architectural prototype, and this could then feed back again into the representation. Thinking about manufacturing, fabrication, construction constraints, then there might be also grammar rules that restrict the expression or evaluate the shape or the solution in different aspects. Thank you for your kind attention, and feel free to ask any questions that you might have about our research project.
Hey, thank you very much, Manuel. I think that we already have one question. Can you see the chat from Michael O'Neill?
Not yet. I'm just stopping the screen sharing, going back to the chat. Fascinating talk and approach, Manuel. Thank you. On the initial image input used as a design reference, perhaps there were a number of inspirational forms we might wish to capture. Could you use multiple images for potentially allow a fusion of ideas? For example, using a multi-many objective algorithm. I think that it should be an optimization algorithm in this context. Yes, indeed, that's possible. Like not with the framework as it is implemented now, but with the conceptual framework, this extension of using multiple image is something that is potential. And then thinking about fusion of ideas, there could be a mapping process between conceptual ideas and the shapes that are generated from those shapes, because now it's a feature-based comparison that kind of is pretty straightforward, but having this conceptual level would need to label a respective data set for categorization. That's something that would be really interesting in this context. Now, using the Muehlbauer objective algorithm in this context, we always thought about being more interesting for architects to have more performance measures and having the potential to generate like simulation overlays in terms of the visualization. So that was the way we were going there. But yeah, okay, now I get what you actually meant. Yeah, it is actually very easy to apply the shape comparison multiple times and evaluate it with a non-dominant sort to kind of get this effect, Michael, I think that you were talking about in this question.
Okay, any other questions? As there are no other questions in the chat, I might ask a question myself, if that's okay with you.
You're free? Yes, indeed.
What caught my attention in particular was when you said that you foresee in the future these to be used for mass customization of residential buildings. Mm-hmm. Can you elaborate a little bit on what you envisage for that?
Good. Now I would probably start the answer from the other side, taking the example of wooden architecture, because there we have like the whole prefabrication process already set up, and the tendering process is only necessary to kind of negotiate the prices. Basically, we could take the output of a shape generation process already as input for the whole fabrication and construction process. So having said that, taking the constraints of this process and bringing them into early design is a possibility to start thinking the whole process from the beginning, and therefore capturing additional optimization benefits. So the mass customization aspect is that usually buildings kind of have an underlying principle that is typologically sound. So residential buildings already is a larger category. When thinking about this mass customization process, we will start by houses, because detached houses already is again a larger category, but having a detached house, for example, is typologically a small enough unit to start with having a sound representation and going through the whole process once. And then it's easy to extend to larger residential buildings over all those different facets of houses that are available on the market. Do you want to extend your question, or is that all right?
I think you answered my question. I was just curious about where this might want to lead, or what do you see about this. So I could basically take any answer. I was just curious about what was the thinking behind it. So I think you answered that very well. Thank you.
You're
Are there
welcome.
any other questions? I'm just trying to see, the chat box is quite small for me. I'm trying to see whether there is anything else coming up. We have time for another question if anybody wanted to ask one more final question. Okay, so no more questions. In this case, I would like to thank Manuel. Thank you very much, and a big clap.
Thank you all for listening to my talk.